introducing me, and thank you, Nasreen, for connecting with me and giving me this opportunity to discuss the topic. The topic which I have chosen, you can see here, it is going to be a light topic. No coding here, no tool here, but I believe you are going to enjoy the talk and you are going to use it a lot. So I believe this is the area which is less spoken about. Usually I prefer storytelling and charting kind of topics also to discuss, because it is the topic which is important yet often ignored. So here is the title: My Chart is Lying. And as Jignasa said, first of all, some brief intro about me. She has already told you I'm an educator by heart and I'm a trainer by profession. So my background is I have done PhD in mathematics, and I was into academics earlier, where I used to teach mathematics, statistics, operations research, supply chain management, total quality management, research methodology, a wide variety of subjects. I really love to learn new things, so I don't stop myself to a limited area. And then I started learning and working with data science thing. So data science, statistical research, data visualization, storytelling, these are the areas I'm currently working in. And I usually take corporate trainings. I also work for some content creation, or creating some courses, writing some of the material. I really love to contribute to online research communities or the QA forums, although I'm not that active now because I have a kid at home and I have other responsibilities. But yeah, earlier I was very active on Quora. I've started my journey with Quora. Here are some of my little bit contribution to the community. I really believe in giving back to the society. So I have a blog of mine. You can see learnerworldtumblr.com, and YouTube. I have created some of the videos there. There are many playlists which are incomplete, but I'm trying my best wherever I can contribute, how much I can do that. I also write answers somewhere on research forums and communities, and I also have shared my some of my research papers and slide decks for the audience wherever I can. Now, before I start any talk, I would like you to just pause and ponder on these breakout questions. Now, in interest of time, I would not be giving you a breakout room. I usually prefer giving it, but here I would like to give you more discussions about the chart. So we would be interacting in between the talk, but I would expect, because I believe here all are data science learners, data science enthusiasts, and maybe some of you are already working with data. So I believe you all know how to read a chart, at least the basic level of understanding of how do you read a chart, right? Yeah. I believe you all know the basic ideas when to use which kind of chart. So I believe you have that background, but I ask you one simple question. Do you think there is a lot of misinformation and lies spread by the charts everywhere? Because these days we have charts everywhere, be it newspaper or social media, Twitter, LinkedIn, whatever, television channel, wherever you will see the magazines, they show you the chart, the advertisement, the politicians, everyone is throwing you the charts because they want to convince some of the things, right? And wherever we have too much information, there is a possibility of misinformation. So my talk is going to help you how you can avoid getting that misinformation and how you can stay alert. So how do you handle it? So I would say that after the talk also, you all discuss it with your peer and colleague and come up with your ideas and find the lies in the charts and make a group to discuss all these. Okay. Now, I hope you all can see my screen. Actually, I should ask earlier, right? You can see the screen, and yeah, okay.
Yes, we can.
So yeah, if you want to interact with me in between, you can speak by unmuting yourself, but it would be better if I take up the questions in the end, right? So here is the agenda. I'm going to talk about some common misconception, and then I will give you some charts if you can catch lies in the charts. I'll show you some basic rules. We can't cover them all in one talk, but I'll show you some charts which are technically correct yet misleading. Is it possible the chart is technically correct? It is still misleading. So we will see those things. Finally, some closing remarks. One thing, whenever I'll be showing you some chart, I would say that immediately start reading the chart. So maybe, we will save our time on interpretation part. Okay. First, let's talk about misconception. We all use this quote, right? We are very fond of using the quotations, especially when it comes to a chart. We say picture is worth 1,000 words. Is it always the case? Not really. Are you shocked when I'm saying it is not really the case always? Yes, it is. The timer is here. Can you read the chart? It is about time spent per activity in some countries, France, Germany, Japan, etc. You see this chart is having paid work, unpaid work, eating, sleeping, all these having similar kind of colors, plus the numbers are written here, plus they are using this kind of pie or donut chart, which is not recommended. It's difficult to compare. In France and Germany, people are spending how much time on sleeping and eating. We can't compare. So this chart is having too much cognitive load. When we create a chart, we want to create a simple chart which readers can easily grasp the message which we want to convey, right? We don't want to just throw a chart to make a beautiful picture. So this chart is not incorrect, but still it is not very useful. So too much of cognitive load here. If you look at this chart, can you read it? The timer goes here. You see it's a pretty chart, but not very useful. We don't know how to read it. Some charts are fancy charts, cool charts, but difficult to read. So we don't know how to read those charts. So, or if we know how to read those charts, we need to, wrap our head around those numbers, small color, all the details which are written in the left-hand side. We spend too much time to get the information, which otherwise we can, convey by a simple meme, maybe a table or a text or something else. But this chart is not the way we should use chart for telling a story, right? Basically, there is a difference between infographic and the storytelling. Now, I would correct the quote by adding few more things to it. A picture is worth 1,000 words only if you know how to read it, or if it is conveying the right information effortlessly to the wider audience. I understand that everyone, when they are reading the chart, they might have some subjectivity. Your perception might be different from someone else's perception. But to the wider audience, it depends upon who is my audience. It depends upon what is my context. It depends upon what story I'm telling. But I want to convey the appropriate information without misleading people. So it should not be having any bias or misinformation. Now, I'm not going to talk about statistical biases here, but I hope you got an idea, right? Another misconception, which we always see, is show, don't tell. So usually we give this advice, show the chart, don't tell them in the text or table format, show the chart. It might not be a good advice always. Why? Let's look at the chart. Now I'm showing you a chart. I'm not telling you anything. I'm showing you the chart. Can you read it? Guess what's that? Difficult to guess? Unless you have watched Professor David's talk about data storytelling, you don't know what is it. These are peak breakup times as per Facebook status update. Shocked? So here, if they have added the labels, the titles, subtitles in the text, we can read what is it. Now, when people are more prone to take breakup, maybe on Mondays, maybe after holidays, maybe on, April Fool's Day, or before Christmas, but they don't take breakup on Christmas Day usually, right? So when we add text to the chart, maybe we can explain it better. So what message we want to convey is, it is not always the picture which is important. The text or telling the story is important. So here I'm showing you a chart without telling you anything. Can you read it and figure out what is it? Timer goes on. I hope you people are trying. And you can, tell me if you are finding it little fast. I will slow down. So here, you might be scratching your head. What do you want to show me? Of course, I have given you the labels. So you can read the chart. That I'm talking about ticket volumes received in a company and ticket volumes processed. Probably complaint ticket volume. Okay, here are the numbers, and we have a lot of junk. Numbers are here and numbers are here. But anyways, we have these bar charts which are telling me the frequency or the count. But what do I do with that? Why I'm telling you this chart? Can you come up with some idea? Here is a better version of it. In this chart, I'm also telling you the story. First of all, I'm telling you the story, then I'm showing the chart, and I'm also explaining you why. Now read this chart carefully. Please approve the hire of 2 full-time equivalents to backfill those who quit past year. So completely explanatory title. Without going through another detail, you know what I'm trying to say. I'm again giving ticket volume here, but the chart is clutter-free. I see 2 lines, grade 1, which I don't want to highlight, and the blue one, which I want to highlight, received and processed. And you see, earlier the charts were hugging each other, but after a certain point, I started seeing a discrepancy, and the gap is increasing, and we are not able to fill the gap. So why there is a gap between received application and processed application, and why it is increasing? because of certain event which had happened on that day. So I'm not asking my readers to guess what happened that day. I'm explaining here that 2 employees quit in May and we are not able to meet up the demand after that, right? So I'm also mentioning the data source and everything. These charts are not mine, right? But I'm just explaining these charts. So here I'm telling a story, then I'm showing a chart, I'm also explaining. It is a better, instead of just showing you a chart randomly and leaving you to guess and put your own wisdom there that what I'm trying to tell, right? So it's not a good idea always to just show you the chart. Now we come to the main topic, right? So can you catch the lies in the chart? Try to catch it quickly. Timer started already. Planned Parenthood Federation of America is a non-profit organization of America, right, which offers some services regarding parenthood, pregnancy, and sexually transmitted disease and all those things, right? There are certain groups like conservative Republicans who are, with time they keep on attacking this organization, because this organization, along with other medical services, also offers abortions as one of the services. And some people don't like it, so they have attacked it using this chart. Can you find where is the lie in the chart? Quickly, anyone? It would be great if someone can quickly unmute and tell me, because I don't want to wait too much, but participation will help me to know that whether you are able to read that quickly or do I need to slow down the pace. Anyone? Okay.
I mean, it's abortions and then they are saying cancer. So it's two different things that they are talking about. Is that what you mean?
Okay, yeah, so it looks like from 2006 to 2013, I'm talking about 2 things, 2 services offered by the organization. It looks like abortion is increasing a lot and cancer screening is decreasing a lot, right? And if we pay attention here, it looks like, in a quick glance, it looks like the rate at which one thing is increasing, other thing is increasing at the same or similar rate, right? We are seeing this kind of lines. So the slope is telling me the story that the federation is working on increasing number of abortions every year, and the cancer screening, which is a useful service, is decreasing a lot. So they are trying to attack the Federation of America because they are saying that abortion, why they are increasing that much. But now I will say pause, pay attention to the numbers, pay attention to the small tiny text returns there, right? This is how they fool us with the chart. See, notice these numbers. It is 2,89,000 something, it is 3,28,000 something. So yes, abortions are increasing, I can see that. But let's look at these numbers. It is 9,35,000. See, it is 3,28,000, it is 9,35,000. Where is the catch? They are using different y-axis for both the lines, which is not recommended, right? So they are using different y-axis because they wanted to highlight to the general audience or public or to whomsoever they are representing the chart. They wanted to highlight that the abortion rates are increasing too much and the cancer screening rates are decreasing too much. So they wanted to highlight it, and they have used the wrong y-axis, which is misleading, which is against the design principle. Actually, when you are showing 2 lines in a single line chart, you need to use the same scale for all the lines. Otherwise, you can't compare those lines, right? So if we handle this thing, what we get here is this chart. See here the drastic difference. What we have made is, we have made the scale, we have also marked it is 10 lakhs, 20 lakhs. So abortion rates, although these are increasing, we can see, but the increase is very less. It's almost imperceptible. I can't even see the increase if I just notice the slope. It's very less, but this is decreasing a lot, right? So what we want to say here is cancer screening is decreasing over the years. We don't know yet why, but at least we know the abortion rates are not that much increasing the way they are trying to exaggerate the difference, right? So basically now you know that which of the 2 charts is correct. Technically the second one is correct, right? But it is not the complete story yet. I'm telling you how to catch the lies. So first of all, if you are creating a chart, you need to follow some design principles, so which I will be talking about, right? But if you are reading someone else's chart, don't get deceived by that chart. Look at all those tiny labels and numbers. And if those numbers are not written there, if they are trying to fool you by hiding some of the information, ask them, what are these numbers? Ask them for more data, more detail, more chart before coming up with any decision, right? So now in this chart also there is something missing. It is not complete yet. What is missing? We can see the data is there for 2006 and 2013. We don't have any information about what was happening in between, right? So if we collect the data and if we use that, probably we will get more insight. So I could just fetch this chart from the book from which I have taken the screenshot. So here it is written 2006 up to 2013. We didn't have data for 2008. For rest of the years, this is the column chart or bar chart for abortion rates. And you see the increase is there, but again, it's very, very less. Every year, it's not increasing too much. So this much increase is there, which was highlighted too much in the first chart. Okay, it is not complete yet. Anything else we need to take care? I'm talking about a particular organization, right? So this organization also offers many other services. So it's not about only two services I'm comparing and I'm just, attacking them, blaming them that you are not doing a good job. What all services they are offering? We need to look at that also. So let's look at this. They also offer other services. You can see contraception is going down, then slightly increasing and so on. This one is increasing a lot. This is sexually transmitted infectious disease treatment and testing. So they are increasing treatment and testing for these diseases. They are also having increase in pregnancy and prenatal services. Their other services are also here, right? But we are not showing up all those and we are just highlighted two things and we are, attacking the thing. So I'm not being biased in favor or against any company. I'm not from US, so I don't know. But looking at the chart, the first chart was of course misleading, right? In this chart, still I can see the cancer screening is going down. So why they are not screening women for cancer, maybe cervical cancer or breast cancer, whatever they are talking about? Why they are not screening about? Why they are reducing the pace? Because they should offer these services to prevent cancer. So there is the reason. When we dig deep, the reason is that American College of Obstetrician and Gynecologists started advising reduction in the frequency of those screening tests for cervical cancer for some medical reason. Then the national guideline also came officially in 2012. But in 2009, they got this advice from the medical organization to reduce the screening. So earlier they used to screen once a year, but now they screen every 3 years. And because the frequency is reducing, of course, we are going to see less numbers here. So that is why you see the graph here is going down. Okay, so I hope now you are able to grasp that whenever you see a chart, if it is not your day-to-day news or social media account, which is not too much important to you, if it is something related to your work, pay attention to every detail. Ask for more information, ask for complete information, and dig deep into other things before you come up to any conclusion, right? So I hope you got an idea. Now let's look at it. Can you tell me how this chart is lying? Your timer starts now. So this is basically unemployed.
The years on the left chart and the years on the right chart don't match in the slightest.
Yeah, good catch. Anything else?
The scale.
Okay, yeah, good. You have catched both. So basically there are two errors here in the chart which you told me. This is the data about unemployed adults in Alcorcon. It is a Spanish city. So they wanted to say about unemployment rate in that city under previous mayor and under the current mayor, right? And it looks like, if you don't pay attention, because I told you to pay attention, if you don't pay attention, you quickly read it, what happens is it looks like the pace at which it is increasing, at the same pace it is going down. It looks like this, that at almost similar pace it is going down. So it looks like the current mayor is really working hard to reduce the unemployment rates. But actually it is not the case. Of course it is going down, but here it is yearly data. We have per year data. Here we have just 1 year, so it's monthly data which we are plotting here. And when we are plotting monthly data, the horizontal line is stretched up, so we are seeing this much difference. And second thing, as you have catched, it is 13,300, it is 16 here, and it is 15 right here. So different y-axis. So in this chart, we found two mistakes. X-axis different, Y-axis different. And that is why misleading story. Here is the better version. I'm using the years here. I'm using the same Y-axis for both the charts. Red one is for previous mayor and the black one is for current. We don't have any data for in between. So I can see the scale is now, okay, it is 13, it is 16, it is 15. It was increasing. Now with the current mayor, it is decreasing. We agree to it, but the difference is not that drastic, which they were trying to convey. Right? So this is how we catch the line. Sometimes what happens, some political leader, when they get elected, they want to show after 1 year or few months that how much they have worked for a particular thing. Suppose they are talking about literacy, right? So what they say that, okay, they say in my regime, literacy is just going like this. But they don't show you the picture. Earlier also it was increasing. Probably it is just increasing at the same pace after the person is elected. But they just show you this portion and they just highlight that under my design, it is increasing. So you need to pay attention that if the data is sufficient or if it is too little information, and the scales, of course. Okay. So, this one is appropriate. Now we will discuss some of the rules, right? Data visualization is a topic in which we don't have any mathematical formulas. And wherever we don't have mathematical formulas, subjectivity comes in. That is why I really love mathematics. I am from mathematics because in mathematics, we have all the fixed rules, formulas, all the things are very well defined. So we know whatever way we will do, we will reach the same place, right? Here it is not the case. Here rules are there, some guidelines are there, but rules are still subjective. You need to put your brain there and you need to think what rule is applicable to your case. Let's see some of the rules. First, I hope you might have heard about it. Zero baseline rule. Right? This rule, zero baseline rule, was came in light when Darrell Huff in the book of How to Lie with the Statistics talked about one statement that all charts should start with zero. And that line became popular and everybody started using it. And it is, of course, a good advice, but not always the case again. Let's see, in the case of bar chart, of course, we should start with zero baseline. I believe most of you must have seen the charts which are not starting with this. I'm not showing you those charts right now. I'm just showing you the advice here. But there are very famous charts, Bush tax cut rate, and many charts where they just highlight the difference by showing you this much portion of the chart. So here in the left hand side, I have the chart which is starting with zero baseline. And in the right hand side, I have the same data, but starting with this 300 baseline, right? Now you see, suppose it is population of 3 countries. So what do I see here? It looks like the population of country A is almost thrice the population of country C. It looks like this, which is not the case if I look at the correct picture, right? So basically, when I don't start my bar chart with zero baseline, I usually exaggerate the difference. So if I want to highlight some difference, if I want to show something, I will play around with the y-axis. And it happens in many newspaper articles and TV news channels also. They also show you some charts like this. So be careful. Okay. But is the same rule applicable for line chart also? Any idea? I don't think so. Always.
You can if it's not starting from zero again.
Mm-hmm.
Or like you have just shown here.
Yeah, so actually it is subjective. I have shown you 2 charts, same line chart, whatever data it is starting with zero. It is not starting with zero. Did you see any difference? Am I lying on or misleading on some information or pattern or something here? Not really, because the pattern still looks the same, right? Pattern still looks the same. Just that if I'm using zero baseline, I need more space to show my chart. Right? And here I can just show you the same in less space, but pattern still looks the same. So many times in the line chart, many times it is possible that we use this chart. If we have less space or some other reason, we can use this chart which don't start with zero because the pattern is still same. I'm not playing around with the pattern. Here I was hiding. It looks like B is negligible. Actually, B is having a good amount of frequency count, but I was, neglecting it. Here I'm not neglecting. Right? So I can still start a line chart with non-zero baseline, right? Let's see one example. Now Nishreen will like it. I know her talk title was climate change related, the machine learning model, right? So she might be knowing it. National Review magazine has published a chart like this with a catchy title, the only climate change chart you need to see. Do you think it is appropriate chart? There was a lot of heated debate on this chart, because this is the chart of climate change. Read it. I hope you people are reading it. And average annual global temperature in degrees Fahrenheit. So this is a chart from 1880 up to 2012. Now, what does it say you? It looks like the global temperature is not rising at all, or probably rising very less, because I see a flat line here, right? So if I look at this chart, if they're showing this chart to the audience who is not very good at catching lies, audience will think it's not worrisome. We can just chill. We can just get relaxed. It's not a problem. Global temperature is not rising. We can't see any rise here. Why? Because the C scale. They are using zero baseline, that is fine. But you know, the scale is like this 50 to 25. So, you know, we don't expect 25-degree change in the temperature. Even for this global temperature, Nishreen might have told you already, the half degree, 1 degree or 2 degree temperature rise is big worry, right? We can see the impact. So basically, this chart is misleading. If I show you this chart, same data, same information, but I'm starting with a new baseline. Actual data value was around here, you know, maybe 56 point something. So we are starting with 56, right? And we don't need values up till 100. There is no 100 value here. We don't have even 75. So I'm just stopping my chart at 60 or 59 so that I can now see the difference. So here I can see the change, because here in this particular case, the global temperature is a variable for which even 1 degree centigrade, or sorry, 1 degree Fahrenheit is a big change. So it also depends upon the variable. If I'm talking about salary rise, of course, you know, $1 or $100 will not be a big rise. Please mute yourself, whosoever it is. Right? So here it depends upon the variable also which I'm measuring. Here it is a big difference. In other variable, maybe 1, 2 unit, 10, 20 units, it's not that big, but here it is a big difference. So I'll not be able to see the difference if I make a chart like this, right? Or if I make a chart like starting from 0 and I'm having scale 5 and 10 and 15, it would be too lengthy chart, right? You know, it will be too much height, which we might not be having a space to print that chart, right? Wherever we want to print. So whenever we want to consider when to start with zero baseline or non-zero baseline, actually it is subjective. So it is acceptable in case of line chart, but it depends case to case. It would be better if you want to show the change more clearly, right? That you start your baseline with the lower value or maybe nearby to that value. So how do you choose whether you should have zero baseline or whether you should not have zero baseline? It will, as I said, depend upon the nature of information, your variable, how much space do you have when you want to publish this chart somewhere, and what story do you want to tell in. So as I said, some rules are there, some guidelines are there, but don't just follow them rigidly. Use your brain, think, and decide what is better in your case. And the best idea is, if you are really working on a project and you believe your chart is going to make an impact, they might take some action based on your chart. Then show your chart to your colleagues, your peers, your manager, or somebody who is not aware about, you know, what you are trying to convey, and ask them what they are reading, so that you have an idea whether they are reading it right, or you wanted to say something and they are, you know, interpreting it something else. So it will give you an idea when you are creating a chart, right? Now, I hope these rules everybody might be knowing it already. Quick discussion. When we create a chart, we want the chart to be readable. I don't want to tilt my head to read the names. Although it is technically correct, we all learn, when we learn any tool or library, we get fancied upon learning those functions and lines of code where we can, you know, tilt those labels and play around with those colors and all those things, which is not always needed. This one is much better. It's readable. And of course, you might be knowing, whenever we use a column chart, maybe horizontal, vertical, whatever it is, we plot here the frequencies and the counts. You might be knowing it, right? So we want to compare which one is having highest frequency, which one is having lowest frequency. So I should not show the categories here randomly. Suppose these are some cities and these are population again. I want to see which city is highest and lowest populated city. I don't want to read those things random order, right? Because whenever we create a chart, the focus should be reader should be comfortably reading the chart. He or she should not spend too much of brain and visual computation to understand the chart. So if I sort these values in some order, ascending or descending order, now it is clearly visible which category is having highest frequency, which category is having lowest frequency. So I can see a particular order. So this one, my favorite way of arranging the bars. But otherwise, there is one more way. Suppose these are states name in India. So there are so many states, countries names in the world. There are so many names. So I can also arrange them alphabetically. So I know where I'm looking at. I'm looking at India. I will just pick the letter I and I will see where is India. Right. So this is how small rules which we take care. Here, I'm not talking too much about what to do, what not to do, avoiding the junk chart, tough taste principle, and so on. I'll give you some of my previous talks if you want to know more about it. Now, I hope I'm not fast, everyone. I believe you know why should we avoid 3D plots? Why do scientists, statisticians hate the pie chart also, right? Although it's very commonly available in dashboards and social media sites, but we should avoid. 3D charts looks cool, but not readable. Look at the chart, or basically misleading. I would say misleading chart. Look at the first chart. Tell me, what do you find out from the first chart? It looks like
the first one is the highest. Like our company is doing really good. Where
yeah. So why so? Because I'm using 3D. So in 3D, we distort information. It looks like whatever is in the front is having the biggest size, whether it is a pie chart or line chart or column chart, whatever, but the front one looks very big as compared to other. So here it looks like it is, much smaller than our company's sale, right? But same data, if you plot in 2D, it looks like this. And now we know the truth. Competitor one has more sales than us. Right? So to hide the truth, they show you this kind of chart, and they also highlight it, writing the text like this, right? Another example, they are highlighting the company sales have sold, and in 2018 record sales of $35 million, using the text and all those things. But if you compare actually your own company sale past few years, so you see it was having a peak in 2013. It was also having a peak in 2011. We don't have numbers written here, so I can't read actually how much it is. It's also not the best chart, but at least it is better than this. So I know it is not the only peak I had. I think the peak here which is higher than this one, right? So 3D charts are you must avoid it. If you are creating, must avoid it. If you are reading, then I can't help you, but you need to think on it that they might be hiding something. Okay. Avoid truncating. Truncating? You can see it here. Look at the numbers. Yeah. So biggest population of America. So different countries here, their population data here, because they wanted to show or fit the chart in a limited space. What they have done, they have truncated. Okay. So it should be avoided. Although the person who is comfortable reading a chart will be able to read it correctly, but still it is misleading for wider audience, because the first glance it looks like it is this much higher than this much. Suppose Colombia's population is around, I don't know, 48 or 50. It looks like it would be something 70 or something, but actually it is 150. And this one and this one, because of this thing here we have 50 million people inside this white line. So it becomes difficult to compare those things. Let's see the better version in the same space, just changing the scale. It looks like this. So here it is the appropriate representation of the same chart. Just one issue here is that when I represent it like this, it becomes difficult to know what is the population of the smaller countries, right? But it's not a big deal. We can use the right aesthetics. We can use some text and right set of colors to read those things, right? Or if it is required, if you have too many countries and if it is required, you might want to create a separate chart for that if you really want to show that or highlight that. But otherwise, using some text here and using appropriate choice of color will help you read that chart better. Okay. Now, I hope you can read this chart. It's a very small chart which is talking about too little information. We have already seen some chart earlier where we have shown too little information to convey a story. Okay. Can you tell me if there is anything wrong with this chart? Or what is your conclusion if you read the chart? Can you tell me?
I would mistakenly assume that the vaccine is causing, has a stronger input to this data.
Okay, so how, why did you add the word mistakenly? What's missing here? It's the data saying that more people die because of the vaccine.
No, no, because it's not giving the full information. It's not giving the population information.
Yeah, it's not giving the information about the denominator. It's not giving the information about total population. I'm talking about 40 children died because of smallpox. I'm talking about 99 died because of reaction from the smallpox vaccine. But I'm not talking about out of how many. This 40 is coming out of how many children, and this 99 is coming out of how many children. So sometimes they show you some numbers without showing you the denominator, right? And which can mislead. It looks like, and if you see the compare this, or if you look at the number, of course, first glance it looks like, okay, you should not go for vaccination, right? But actually, whenever you see such data in which they are comparing something and they are asking you to rely on something, you might also want to know about denominator, right? So if we consider the denominator, we come up with this chart, although I believe it is also incomplete, but what they are showing here is children who died because of smallpox or the vaccine against it, 139. So it is 40 plus 99, 139. It is the number of those children who died, unfortunately, right? Now, very big number, 4,000. It is the number of children who would die if vaccine hadn't been widely applied, right? So here we are trying to highlight that if we don't apply, or if we didn't apply the vaccine to a wider audience, these many children would have died. But because the vaccine is applied, so because of vaccine reaction or otherwise because of the disease, these many people died. So here again we are comparing, but still we don't know out of how many, right? So we need to know more about it. So too little information
Can I ask a question on this?
Yeah, sure.
Just out of curiosity. So here we are talking about children who died because of smallpox and who would die. So isn't that also misleading, because these two is comparing one that has happened and one would happen? So it's an approximation of it. It's not a real data. What are your thoughts on that?
Yeah, actually it's not real data, of course, because those who died, we know how many died. Those who did not, we don't know. But basically we are using here the probabilities, right? How many children can die or could die if we don't use the vaccine for that disease. Like in COVID cases also, we have seen before, the vaccines came to the market, and still today people have controversies for that. So they show this kind of information that if we provide that vaccine, we can reduce the death by this much based on their probability calculation and their estimate, of course, right? So that is also the case. And I'll, because you have raised this thing, I'll also show you one chart where we need to be careful about estimates also, right? But for now, let's also see that if we add numbers or complete information to the chart, how can we better read the chart? So you see the information is here on the right hand side. Out of a total population of 10 lakh children, okay, 9,90,000 got vaccinated. Okay, so they have vaccinated to a wider, gentry, and 1% of those, you can see this number is just 1% of this. I'm just removing 2 zeros, so it is 1% here, right? They had a reaction. Okay, those who had a reaction, it might not be a serious reaction, something mild, but out of those 1% children died. So basically those who got vaccinated, 1% into 1%, it means 0.01% children die. So if a child take vaccine, what is the probability of dying with side effect of that vaccine or reaction of that vaccine? 0.01%, right? It means in 1,000 or maybe in 10,000, roughly one child can die, right? So of course it is also unfortunate, but it is a small number. Look at the right hand side. I'm talking about those 10,000 children who didn't get vaccinated. So these children had no vaccine. They caught a smallpox. They were infected with smallpox. Out of those, because this disease is, a challenging disease, so 40 children died here. So it's a big number. Why this 40 is big and this 99 is not big? Because this 99 is coming out of this population of 9,90,000 people, and this 40 is coming out of 10,000, right? So here, if we look at the percentages, this is just 0.4%. Sorry, this is 0.4%. Right? So basically, it's a big number as compared to this. If you see probabilities, it is 0.01% chances and it is 0.4% chances. Right? So this 40 was coming out of 10,000 and this was coming out of 990, this. And that is why when we do the math, it looks like this one is more problematic. Right? So basically, when we create a chart, of course, we don't want to show such chart to the audience. Right? If the audience is non-technical and they can't understand number, and there are few people who are allergic to math, when we show them probability, this word, when we show them numbers or percentage, they feel scared. Okay, if we want to present it simply, fine, but at least we should show them relative number instead of saying 40 or 99. Maybe we write the percentage here. Right? So, and we write the complete text here, what we are talking about, those who got vaccine, those who did not got vaccine, everything, so that they can understand it better. Right? So if you want to simplify the chart, perfectly fine. We use chart because we want to simplify the information which we want to present. Instead, rather we can use table also. But most of the time in data storytelling, we, use a smaller tables or probably charts. Added with the text and annotation, so that we can convey the story or we can explain the chart to the audience which is not technical. And even the technical audience, we are not comfortable reading too many numbers and processing the information and doing the mental calculation visually. So we prefer charts, but the chart should not mislead us by showing the little information. If you are creating a chart, you don't want to mislead anyone intentionally, but unintentionally also try to avoid these mistakes, right? Be careful what you are presenting, right? And of course, you show it to someone else so that you know what is missing there in the chart. And maybe what you can do is, if you are reading someone else's chart, you can discuss it with your colleagues. If you really want to improve upon this skill, which is very important skill, you can, these days we have charts everywhere, Twitter, LinkedIn, whatever. So discuss it with your peers. What did you understand? What did they understand? Okay. Now, the reverse is of course bad too. Too much information is also not appropriate. Too much means sometimes what happens, somebody wants to lie you and they throw you too much information so that the actual message just swayed in that. You can't see the actual pattern on the data. So that is also not appropriate. Right? Now I'm just, I will just explain about this rule. So here in fertility rate, if we see, you might be knowing 2.1 is the replacement rate. Means fertility rate, that average number of kid of a woman who is average number of birth a woman can give or woman gives in a particular country or city, that is fertility rate. And replacement rate is average standard 2.1. So it is believed that if 2.1 is the fertility rate, we will be able to replace our generation. We will be having sufficient kids who will be replacing our generation. So the dotted line shows that thing, right? And this chart, children per woman, each gray line is a country. So many countries data here it is. With this chart, data is coming from a reliable source. They wanted to highlight that over the years, fertility rate is going down. Right? They wanted to highlight it, but you can't see the pattern because it is difficult to see which country is going where. Too many lines here. I can't read it. At least I can see the red line for European Union and maybe the average is going down, but I can't see it for other countries. For this, they have written the numbers also, right? So too much information is also bad. Yeah. Anyone saying something? Okay. So what can we do with this chart? Of course, if you are creating a chart, don't show everything which you have. Sometimes when we are exploring data, we do those IDEs things I think the beginners always do those R Python libraries, quickly creating the plots. Okay, there are so many rules you should know when to create with chart and many other things. But anyways, you are creating. You don't need to show all your charts in the project report. Too much information is also bad. Whatever is your finding after doing a good research, just show that, right? Okay, so here also we have too many lines. What can we do? Probably we just find the information. Fertility rate is going down in the countries, they are saying that. Probably it is going down in the countries which are poorer countries because they can't afford to have more kids, right? And the companies which are wealthy countries, probably it is not going down there. Let's see it. Just a moment. Okay, let's see it. Low income, middle income, high income countries. So for high income countries, it is almost stable. I don't have number here, so I can't read, but it is almost stable. For lower income countries, it is of course going down, probably because of the same reason. Poverty is there, right? Okay, and world average is this one, the black line. Or maybe if you want to highlight information about particular set of countries, you can use a separate chart. These days in the libraries, we can quickly create those faceted chart. So see, for countries like Albania, of course, it is going down a lot over the years. The dotted line is the replacement rate, right? But for the countries like France, it is increasing. For the countries like Germany, it is stable, right? So different countries have different patterns. But in that chart, I was not able to read it. What country, what pattern? I was just believing, okay, probability is going down for all the countries, okay? So this is also not appropriate. Now I will talk about technically correct yet misleading chart. So we have already seen some chart which were technically correct. I will show you some more. It is again the global temperature change. Did you see it is different? It is temperature change data. Earlier I was showing you global temperature data in Fahrenheit. It is temperature change data in degrees Celsius, and this is the change over the years. I think same range here from 1880 up to 2012, something like that. Okay, because I'm presenting here the change, so I have these numbers here on my y-axis. So I can see after a particular time it's going up, and it's going up, and the increase is very sharp. Is it worrisome? Looks like. Now look at the chart, same data, same line chart, same years, everything same. What happened to my chart? It looks flat now. It is a misleading chart. It looks flat because what I have done is I have stretched my y-axis. So my data was going up like this, sharp rise, and because I stretched y-axis, it's now flat. So I'm trying to hide the change, right? So it is misleading. This is also, technically this is correct, but misleading. Let's see this one. Here also, I see almost a flat line as compared to this one. What's happening here? I'm stretching out the x-axis. So again, we have seen that if we stretch out x-axis, we can see the pattern is changing. That is also not appropriate, right? And as Mr. Shivani says, this is also right, this is also right. Whenever you have conflict, you need to assume both are right. Here it is not the case, but technically it is correct. I'm not using anything wrong here. I'm using the scale and everything. What about this? Same data, same chart. I'm just playing around with the axis. So you notice here, I'm shrinking my x-axis. So when I'm shrinking my x-axis, the difference looks exaggerated. It looks too much. Probably you will get a heart attack looking at the chart, right? So how do you decide? The bigger question is, how do you decide? I give you data. It's an Excel sheet. You have years here, you have temperature change here. How do you decide which one is appropriate? How do you decide the aspect ratio? It's the big question, right? So basically aspect ratio, again, you need to decide. There are some certain rules or thumb rules, but of course it will depend upon the data, right? So if you want to know more about aspect ratio, the great explanation is there in Alberto Carrio's book, from which I have taken many of the chart. I'll give you the book name also after the PPT, but actually it depends chart to chart, right? So again, you need to take your own call. Nobody will give you a perfect formula that for this data or this kind of chart, always use this aspect ratio, right? It depends upon the variable you are measuring and some other things. Of course, it also depends upon how much space you have and so on. Okay. Now I'll give you a question. I hope I have given you too many insights about finding lies in the chart. Now, can you read the chart and see if there is anything wrong with the chart? What is your interpretation? Are you trying to say me, the more cigarettes we consume, the more we live? Do you think so? I think you know it is a scatter plot. And I believe you know how to read a scatter plot. Right? We all do it for data exploration part. Whenever two numerical variable, okay, put it on a scatter plot and find the correlation and write the findings. Variable X is related with variable Y. Variable X is linearly related with variable Y. This is the amount of strength of linear correlation. All those basic stats we do, right? But here I'm finding this, which is a strange, isn't it? We all know that smoking is injurious to health. If we smoke more, oh, sorry about that. If we smoke more, we are, going to lose years in our life. So why this is the pattern? Anyone, any idea? Notice this? Any other idea? Any other pointer? It's simple thing. If I say that in my city it is raining this much, I have amount of rainfall, and I have amount of maybe students who are committing suicide, and I'm saying I'm finding high correlation. What is it? Is it justified that more rain causes students to suicide? Is it justified? Wherever you see any pattern, scatter plot is good to see the pattern, but you need to use your brain. Is it justified that those two variables are related? Can I say that? Yeah. Andrews, you were saying something? Can I say that if we smoke more cigarette, we are expected to live longer? Can I say that? Because
Logically,
it looks
no.
like, yeah?
Logically, no.
Logically, no. So what's happening here? There are two things to it. First of all, you might have heard it. Correlation is not causation. So if your data tells you a correlation value, it doesn't always mean that there is correlation, right? Sorry, causation,
Okay.
right? So first of all, the story, we all have heard it. So basically, wherever there is a correlation, we don't directly jump into the conclusion that because of variable X, variable Y will always go up or go down. We don't jump directly, right? We need to think logically. And of course, in this example, we know it is not possible, right? So we are having something in our mind, maybe something is, fishy here. What's fishy here? Maybe whenever you see such pattern, what can happen? Few reasons can happen. First thing it can happen is that this pattern you are seeing because of some other variable. There is some third variable, right, which is not there in the plot. There is some other variable which is showing you this relationship. Probably there is a variable in the data set which also affect this, which also affect this, right? It can be possible. So probably because of that variable, interaction effect or confounding, whatever you say it, because of that variable, probably both variables are increasing simultaneously and you are seeing this pattern. So that is one thing here. I'll explain that also. Another reason is that maybe it can happen because you are using aggregated data here. This data you see here, each dot is a country. It's not a data of single person. It's not me who is smoking this much and living up to this year. It is a country. So in that country, we have population, so many people, right? And it is the average of those people. So we are aggregating the information here. So maybe because of aggregation, we are seeing the pattern, or maybe just the opposite. Sometimes we are, taking out the subsets, and because of that, we are seeing the pattern. So that can be the thing. Another possibility is sometimes just by chance, we can get such kind of spurious patterns or spurious correlations. So just by chance, these possibilities are there, right? Now we will see this example, and I'll also a little bit talk about it if we get time. So let's see, I'm talking about third variable. I thought that probably there is some other variable which can affect these two things. So if we are talking about wealth of the countries, I'm having three group of countries: high income, middle income, low income countries, right? So I want to see that information. Okay, what is the data for these different countries? You might be knowing that in the libraries which we use these days, we can create a chart in which we can give colors to different categories of another variable, right? In bubble chart, we can add up to 5 variables. Very smoothly we can add, and we can also create interactive charts very quickly so that we can explain, right? There is a wonderful talk on Gapminder. You will see those nice interactive videos and charts and talks where they can explain the interactive chart. Let's not go into that. Here, these are high income countries, the black one. The blue one, all these are middle income, and the red one are low income, right? What do you read? Because it's difficult to read, let me make it simple by faceting the chart. Looks like this. High income countries. What do you read here? In high income country, what is the life expectancy? It is higher, right? As we expected, because in the rich countries, they have more access to healthcare. There are less people living under the poverty line and having starvation. They have good hygiene habits and good personal care and all those things. They have less mental illness and all those things. Their life expectancy is more, right? What about cigarette consumption in these people? Too much variety. You know, variation is too much. Somebody just doesn't smoke. I mean, some country, and some countries having high smoking amount. So too much variation in cigarette consumption, but high life expectancy in this country. Of course, we can have exception, right? In middle income countries, it's always, you know, middle thing. So this is also having a lot of variation. Life expectancy can be as low as this and as high as this, a lot of variation. Cigarette consumption, a lot of variation here, right? The pattern is there, increasing pattern is there, but comparatively it is weaker. It's not that a strong pattern, it's comparatively weaker, right? Let's talk about the lower income countries. Lower income countries, you see, what about the cigarette consumption? Very low. People can't afford to smoke too much, right? So that is low. What about the life expectancy? It's low comparatively, but still it has a lot of variation, right? So if we use more information, you will be able to find more insight. May not be always the case, but yes, you need to explore that, right? Okay, what about these middle income companies? It looks like still there is some positive pattern. Why so? Another reason can be, as I said, aggregation. This is the data for countries, right? So sometimes what happen is I'm using aggregated data, right? Summarized data for entire population or entire countries. Using that, I can't make any conclusion about the states or districts or cities or maybe individuals, because those are different from the countries, right? So I can't make any statement about those individuals. Similarly, if I have data about individuals, I can't make any statement about the entire country, right? So if we have used aggregation in the data, a chart which is used for aggregated values, a chart which is using the individual values, can have different patterns. They can also have the inverse relationship. It is possible they can have, right? Probably the average is coming out to be high, probably because of population or something else, right? So we can't use the aggregated data to make any conclusion about the individual, and sometimes the pattern just go reverse, and this paradox is known as amalgamation paradox, right? So we have discussed too many things. Now I don't want to shower you too much with so many plots, because you know it becomes heavy when we read too many charts in a quick glance. Now my final concluding remark is, don't let anyone deceive you or fool you by a misleading chart. Take your own judgment. Choose whether the chart is appropriate or not, with, you know, before making any decision. We have summarized, we have discussed many examples. A chart can be misleading if it is poorly designed, means against design principle. You know, wrong y-axis and stretching out x-axis, all those things. Using wrong data, of course. If I'm using the data which is not reliable, it's a big worry. Or biased data, of course it is bad. Using too little, too much information. If it is confusing the uncertainty. Suppose the chart is based on some poll results, survey results. So in those survey results, we are estimating something. We don't have population. We are making some claim about the population. So when we make little bit of stats here, sorry about that. When you make a claim about population parameter, we call it point estimation. And in that point estimation, we always have some margin of error, right? So if you don't show that margin of error in the chart and you believe that point estimation is 100% accurate, of course you are misleading, right? And you can have misleading patterns, as we have seen in the cigarette example, so many such examples. Now, I hope
Nisha, sorry to
Yeah.
interrupt, Nisha. We are running out of time.
Yeah,
Could you
I'm
please,
just winding it up in 1 or
Yes.
2 minutes. Yeah, thank you.
Yeah, and I think there's a question in the chat box. Please, can you
Okay,
answer?
okay. I'll just check that. So I think I tried to make you better at reading chart to some extent. We have done it passively. We have not taught you this thing, but passively we learned something. Catching lies in the chart to some extent, chart designing rules, some of those, and seeing the complete pictures, right? But if you want to know more about chart designing rules, avoiding jumps, knowing about the context, the audience, data storytelling principles, and much more, you can see my talk on my YouTube about storytelling with data. Here I have discussed too many things about particularly storytelling. And in the playlist, we have many other talks about selecting the appropriate chart and so on. Here are the references which I have used. I was talking about the book by Alberto, How Chart Lies. And this book is also great, How Do We Lie with Statistics? And this is my favorite book for data storytelling, right? And this is also a great book, Hands-on Data Visualization, where you have practical implementation of charts also, as well as the theory and rules and all those. So many great things, many great resources. I want to confess here, I have not created any of these charts and images which I have shown you. These I have taken from the books and web resources mentioned in the PPT. Now you can of course follow me if you liked my talk and you want to read more about my post or my videos, you can follow me here. Or in case you have any other speaking or collaboration kind of opportunity, you can drop me an email here. Now time to look at the question. And of course, thank you for
I think
listening
maybe
to
we
me.
can, if you can answer them in the chat to the person